All right, this next topic of notes covers 3 learning targets, and it's all about inequalities. So the first thing I'm going to have is just starting with a basic inequality, and we use our less than and greater than symbols, or the or equal to symbols. So you solve inequalities just like you solve an equation. So for this first one, as if it said 3x equals 15, we're going to solve it the same way. So we're going to divide by 3 on both sides. So I get that x is greater than 5. And then on our next one, 5x plus 2 is less than or equal to 9. Again, as if this was an equal sign here, I'm going to do minus 2. And I get that x is less than or equal to 7. Okay, the next one, there's a special rule when you multiply or divide by a negative. So if I have this, negative 2x is greater than or equal to 14, and I divide by 2 on both sides, what I'm going to do is flip the sign in the middle to go the other way. So if you multiply or divide by a negative on both sides, you have to flip the sign. That's very important to remember. Okay, so on our next one over here, I'm going to multiply both sides by negative 5 like I would a normal equation. Those will cancel, and I'm left with x on this side and positive 30 here, but I need to flip my sign, so instead it's going to go this way. So now it's x is greater than 30. And it became a positive 30 because a negative times a negative is a positive. Okay, now we are going to jump into some examples with solving them and then graphing them. Okay, so for our first one here, we need to deal with our distribution. So I'm going to distribute first, just like I would a normal equation. And I have negative 6x minus 6 is less than 10. I'm going to add my 6 over. And I get negative 6x is less than 16. Now I'm going to divide by negative 6. So here I'm left with x. Now remember, because I just divided by a negative here, I'm going to have to flip my sign to go the other way. And then 16 divided by 6 does not work out evenly. It's approximately negative 2.6 repeating, or you could simplify it down. So I could take 16 over 6 and make it 8 over 3 by dividing by 2 on the top and the bottom. So you could do this, or you can do 8 over 3. Now I'm going to have to graph this on the number line. So to graph it on the number line, I would at least plot 3 numbers. So the first thing I'm going to plot is the number that I solved for, so 8 over 3. And if you want to use decimals, that's fine too. And then I'm just going to take one bigger and one smaller than that number. So I'll do 7 over 3, and then I'll also do 9 over 3. Now, if you look over here, this is going to tell you how to graph it. So I have, let's see, this symbol right here. That means that I'm going to use an open circle on my graph. So on 8 over 3, I'm going to make an open circle. And then I'm going to shade it in the direction that it needs to go. So if it says x is greater than that number, I want to shade towards the bigger numbers. So I'm going to make a line that goes this way. Okay, let's try it again on the next one. So for this one, there's no distribution, so I'm just going to start by moving the terms over. So I'm going to start with subtracting the 2x. So that cancels, and I have negative 5 is less than or equal to 3x minus 22. Now I'm going to add 22 to both sides. So I'm left with 17 is less than or equal to 3x. I'm going to divide by 3. Now again, this isn't going to work out evenly, so we could do this one as a decimal. So I'll do 5.6 repeating for this one. It's less than or equal to x. Now this one is written a little bit differently if you notice the x is on the right side. So if you want to, you can rearrange this, but make sure that you do it correctly. So see how the mouth is eating the x? When I rearrange it, it has to be that same way. So I could make this x is greater than or equal to 5.6. And these both say the same thing because on both of them, it's opening towards the x. Okay, so now I'm going to graph this. So I'll do 5.6 in the middle, and then maybe I'll just round up to 6 over here, and I'll go down to 4 over here. Now this one has an or equal to, and so if you look over to the left again, that means I'm going to have a closed circle. So you're going to fill in the circle here. And x is greater than that. So again, I'm going to shade this way. To the right towards the bigger numbers. And sometimes people get, honestly, the most confused on the number line. So if you need to make yourself kind of a number line that goes like this is bigger and this is smaller, sometimes that's one of the biggest mistakes on the shading is which way is which. Okay, we have a couple more here that are a bit more in detailed. So let's try those. I'm going to take this negative 3 and I'm going to distribute it. So I have negative 6x plus 15 is greater than or equal to negative 6x plus 9. So I'm going to move my x over, plus 6x plus 6x, and I get that 15 is greater than or equal to 9. Well, if you notice, my x's went away, and I don't have anything left. So I want to see if this statement is true or not. Is 15 greater than or equal to 9? Yes, it is true. If it is true, we have infinite solutions. To graph infinite solutions, you just make like a line above or on the graph to show that it goes infinitely in either direction. You can use any number. Okay, so on our next one, I'm going to take the 2 and distribute. I have 4x minus 5 is less than 4x minus 6. I'm going to subtract my 4x. And I'm left with negative 5 is less than negative 6. Is that true? So this is not true. Negative 6 would be the smaller number. So this is false. And if it is false, it is no solution. And when there's no solution, you leave the graph blank. You don't put anything on it. Okay, the next we have a real world application. So Derek is ordering some roses online, and he wants to know if it's cheaper for florist A or florist B. So the first thing you want to do is set these equal to each other and see when they would be equal amount, like at how many roses. So florist A is $4.75 for each blue rose. So I'm going to put an X there, plus a $40 delivery charge. Now florist B is $5.15 per rose, but a $25 delivery charge. So now I'm going to solve this. So I have to move over my 4.75x. I'm going to subtract that from both sides. So I get 40 equals 0.40x plus 25. And then I'm going to subtract 25 from both sides. So I get 15 is equal to 0.40x. And I'll take 15 divided by 0.4, or 0.40. And I'm going to get that x is equal to 37.5. So that means at around 37 or 37 and a half roses is when they are equal. So I want to figure out which one I should go with. So I'm going to make myself a little chart over here. And I'm going to have florist A and florist B. And I want to know what their cost is just above and below that so I know what I should go with. So I'm going to do, say, 37 roses, and then I'm going to do 38 roses. So for florist A, for 37 roses, I'll write out this first example here. You would do 4.75 times 37 plus 40, and that would tell you how much that is. So 4.75 times 37, and then add 40, you would get 215.75. Now we're going to do the same thing for florist B. Florist B would be $5.15 times 37 plus, 25. So 515 times 37 plus 25 is $215.55. Now I'll do the same thing for 38. So 4.75 times 38 plus 40 gives me $220.50. And $5.15 times 38 roses plus $25 is $220.70. So at 37 roses, it's cheaper to go with florist B, and at 38 roses, it is cheaper to go with florist A. So that means that 37 and below, you should go with A, and 38 or above, you should go with B.